Hi students, today I am going to explain what are aromatic compounds. So aromatic compounds are the compounds which have a characteristic aroma, means a sweet smell. So what are its characteristics? Let's see. They will be cyclic. The structures will be cyclic and there should be planar and conjugated. Conjugated means alternate single and double bonds, and they should follow Huckel's rule, means they should have 4n plus 2 pi electrons, means odd number of pairs of electrons. 1 2 3 3 pairs, 1 2 3 4 5 pairs. So like this 3 1 2 3 4 5 6 7 pairs. Like this odd number of pair of electrons should be there, not odd number of electrons, odd pair of electrons. So 1 2 3 pairs. It's no 6. And all the p orbitals must overlap. Then only it is an aromatic compound. So like this we can decide whether it is an aromatic compound or not. So examples of aromatic compounds are benzene, naphthalene, pyridine, anthracene, etc. So what is aromacity? Aromacity is defined as the ability of a compound to sustain an induced ring. It will sustain its ring structure. So I told Huckel's rule, it should follow Huckel's rule. What is that Huckel's rule? Let's see. So according to this rule, a cyclic compound must have odd number of pi electrons. So there should be odd number of pi electron pairs. So which obey this rule, the molecules which obey these rules are called aromatic compounds, and molecules which obey partially this rule are anti-aromatic or non-aromatic compounds. Then delocalization is also possible only if atoms sharing electrons lie in close to the same plane so that their p orbitals can overlap efficiently. So when the p orbitals overlap efficiently only, then delocalization takes place. So there is connection between the p orbitals overlap and the delocalization. So what is delocalization of p orbitals? So the atoms will be delocalized, means there will be alternate double bond and double bond and single bond, and they will be rotating around in a planar structure, and there will be resonance structures possible because of this rotating of the pi electrons, or double bond will be rotating. So if we take benzene, this double bond may come this side and this will become single, and this may rotate here. Like this there will be delocalization of the electrons. This is possible only when the p orbitals are effectively overlapped. So this is Huckel's rule. For example, if we take benzene, so we know that there are 6 pi electrons, right? 3 pairs of electrons, so 6 pi. So it follows 4n plus 2 pi rule, 4n plus 2 rule. So 4n plus 2 is equal to 6. So 4n is equal to plus 2 will go this side. So 6 minus 2, 4. So 4n is equal to 4 and n is equal to 1. So whatever is the n value, if it is 0 and more than 0, means all positive integers, then this Huckel's rule will be met and it is a aromatic compound. So then what are non-aromatic compounds? Let's see. If they don't have planarity, if they are having lack of planarity, or delocalization is disrupted, or they will not follow, they may contain 4n or 4n plus 2 pi electrons, but some problem in planarity or delocalization, then they are non-aromatic compounds. For example, like cyclopropene. When we take cyclopropene, it is a non-aromatic compound. See here, 2 electrons are present. So 4n plus 2 is equal to 2. So 4n is equal to 2 minus 2, that is equal to 0. So n is equal to 0. So it follows the rule, Huckel's rule. But what happens? Here the delocalization is interrupted because of sp3 hybridization. Actually, all the p orbitals should follow, all the aromatic compounds will have sp2 hybridization. But here, because of sp3 hybridization, this is not an aromatic compound, it is a non-aromatic compound. Then we'll get what is the difference between non-aromatic and anti-aromatic compounds. Cyclopropenyl cation, the same cyclopropene, when one cation is there, yes, no, then it will have 2 electrons same, and n is equal to 0. Huckel's rule is satisfied. And because here empty p orbital is present, there sp3 hybridization, so it is not an aromatic, we told it is non-aromatic. But here because of the cation present, it is having empty p orbital. So delocalization is possible here because cation induces this delocalization. So it became aromatic compound. Then we will get what is anti-aromatic compounds. So it is a planar structure and it will be a cyclic and conjugated, but here it will follow the 4n pi electron rule. In aromatic compounds 4n plus 2 pi electron rule, but here 4n pi rule, and it will having even number of pair of electrons. In aromatic compounds odd number of pair of electrons, but in anti-aromatic compounds even number of pair of electrons will be there. For example, cyclopropanol anion if we take, so here 4 electrons are present. We know that 4n is equal to 4 and n is equal to 1. So here it is following the because of 4 electrons, even pair of electrons. So it is an anti-aromatic compound. In anti-aromatic compounds, it will be having planar, cyclic, conjugated, same like aromatic, but it will follow 4n pi rule. So that is the only difference. So it is an anti-aromatic compound. Then, so when we see aromatic compounds are more stable than normal cyclic compounds which are present, and cyclic compounds are more stable than anti-aromatic compounds. So aromatic compounds are the most stable form. Then what are anilines? So the monocyclic hydrocarbons with alternate single and double bonds are called anilines. So these are the monocyclic, we should remember. Only one cycle should be there. So the monocyclic hydrocarbons with alternate single and double bonds are called anilines. For example, if we take a 4-aniline means butadiene, so cyclobutadiene, if we take, so 4 electrons are there, 2 pairs of electrons, so 4 electrons. So it will follow 4n rule. Yes, no. So 4n is equal to 4, n is equal to 1. So and because it follows 4n rule and even number of compounds, and it is cyclic planar, it is an anti-aromatic compound. So then cyclobutadienyl dication. So for same cyclobutadiene, if 2 electrons are removed, so it becomes dication. 2 electrons will be present and it will follow Huckel's rule, 4n plus 2 is equal to 2, so n is equal to 0. So it is aromatic because it has cyclic structure, planar structure, conjugated, and follows 4n plus 2 rule. So it is aromatic. And then when we take 5 cyclopentadiene, 5-aniline, here also 4 electrons are present, 1, 2, 3, 4. So it also follows 4n pi rule and no conjugation is there. So it is a cyclic planar structure and it is also planar, but no conjugation is there. So it is not anti-aromatic, it is non-aromatic. So we have to remember no conjugation or any disruption in the delocalization, then it is non-aromatic. So when we take out electron, then it will become cyclopentadienyl cation. Then it will follow 4n pi rule, but conjugation is there because this cation will induce the conjugation. So it will become anti-aromatic compound. Then if we take anion, so if we add electron to this, it will become cyclopentadienyl anion. So 6 electrons like benzene. So n is equal to 1 and it is also cyclic, planar, conjugation is there. We know that. So aromatic compound. Then next is 7-aniline. If we take 7, so 6 pi electrons are there like same in benzene. So n is equal to 1. But why it is not a aromatic compound? Because 1 electron will not contribute for conjugation. So that is why it is a non-aromatic compound. Then if we take cycloheptatrienyl cation, so what happens? It will become aromatic. So it is we already know it is a cyclic, planar and conjugated. This cation will induce the conjugation. So like this we can write. Next, octatriene, cyclo 8. So if we take octatetrene 8 aniline, it will have 8 pi electrons, 1 2 3 4 4 pi, so 8 electrons, but it is not a planar because of puckering of ring, because of some ring strain is happening here, so it will become boat shaped. So it is a non-aromatic compound, but it should be actually anti-aromatic because it is following 4n pi rule. Because of this non-planar structure, it is becoming non-aromatic compound. Thank you.